Hello and welcome back to my YouTube channel. In this video, I will try to show you how we can configure Oracle TDE with Oracle Wallet. Of course, the Oracle version will be Oracle 19c. So before we get started, I just prepared a document or a small list that will highlight all the sections or the steps that we'll go through. So like this, you will be able to track me or stay align with me with each step that I am going to go along with this video. So please, this one just to make it easy for you to understand what I am going to do and keep tracking my illustration or this video in smooth way. Okay, so let's start with a brief introduction about what is the TDE. Okay, and why we need it. So the TDE is Oracle Transparent Data Encryption. The transparent, that's mean no need to encrypt, decrypt by the client or any other client, or by any other program that is connected to the database. So it's transparent database. Oracle database or Oracle engine will handle, or Oracle binary, of course, will handle the encryption and decryption, the processes that we have on the server. It will handle the encryption and decryption of the data while you are connecting to the database and retrieving or inserting data. Okay, so the TDE, Transparent Data Encryption, is an Oracle advanced security feature that helps us to protect our data from being stolen. So you may ask me, why encryption? Okay, encryption will secure your data by prevent the attacker to steal your data if he gain access through direct access to the database storage. That means he able to reach your database data files. Maybe he will able to download them, extract the data or sensitive data from these data files. Theft of database backup. Let's say if you have a backup server and the attacker able to gain access to this server and he will able to like download some RMAN backup or backup sets there, he able to retrieve or restore this RMAN backup or a backup that you have to any other server and extract the same sensitive data. The other things or the other threat that may you encounter on your environment. Let's say if you are exporting data and this data using export data bomb and you putting this exports on the server and the attacker the same again able to download this export, he will be able to let's say restore or retrieve this data, and of course he will have these data and the sensitive data for the organization or the company. So in general, Oracle TDE will prevent on the operating system level. So in case if someone reach the operating system, able to reach your data files on the operating system or backup or export, this feature will protect you from the attacker be able to read the data, because of course he need the master encryption key to be able to retrieve the data. So the data that he have, it will be encrypted and you will be in the safe side in case if you have this such attack happened on your environment. Okay, so let's move to the other section here. The TDE will encrypt targets. So we have two targets here. You can encrypt the table space, that's mean all the data files belong to that table space, or you can encrypt specific columns within the table, which is this one. Here I'm talking in general. The majority are prefer to encrypt the table space for sake of performance. But if you have like a specific columns and you need to measure it and you need to check with Oracle documentation deeply, because this will affect the performance if you are querying this table. If you are indexing this table, there is some other related topics belong to this one. I advise you to go to Oracle documentation, try to get further or more details about encrypting, and especially the performance. Before I go, you need to plan for this one before you going this one. Table spaces, I implement this one for environment. We didn't encounter much issues with this one. Especially if you have a good server with a good CPU, so it will be fine for you. No, you will not feel that there is some intense on the server, on the server, especially on the CPUs. Okay, so the first target is the table space. So the table space, once you encrypt the table space, it's good to know that all the data files belong to the table space, they will be encrypted. Okay, and the tablespace key is same for encrypted data files within the tablespace. That means all the data files, they have the same tablespace key. Okay, and the default algorithm for the tablespace is AES 128. This algorithm for encryption. Let's move to the columns. The columns is the encrypt. This one is encrypted by column in the table. That's mean columns, it's encrypt columns in a table. Okay, or one column or two columns or all the columns. It depends on where is the sensitive data that you need to encrypt. Okay, the table key is same for all encrypted columns within the table. That means if you have table called employee and you have a key for this table, all the columns inside this table have the same key. Okay, and the default algorithm will be AES 192. Okay, so now we finish with this one. You know right now that it's the targets that you need to encrypt. We have two targets only, table spaces and columns within the table. We able to encrypt using TDE, using this feature. Now let's move to the third section here. TDE have key architecture. Okay, the key architecture is important to understand, to know the mechanism of working TDE. Let's see, let's see here. We have three keys: the master key, tablespace key, and table key. Of course, the master key have things it's good to know for you also before getting started technical side or practical side. Master key is a key stored outside the database. That means this one will be outside using Oracle Wallet, using Oracle Key Vault, or any other brand HSM brands in the market. Let's say you have HSM. It stands for hardware management, hardware management or hardware security module. Sorry. HSM is hardware security modules. So now we know that this key is stored outside. Master key is a key encrypting key known as ME key, master encryption key. So this one use it to encrypt keys. Okay, this master key is using to encrypt keys. And master key used to encrypt the table and table space keys. So that means this key use it to encrypt both of these keys. Okay, so both of these keys will be stored and they will be also encrypted. They will be decrypted by this key. Okay, now there is one thing else also good to know about the master key, is that the master key can be generated by wallet or key vault or any other supported HSM hardware security modules. So that's mean you need to have wallet or any other technologies to generate this master key. Note that if you are using hardware security modules, I prefer to check if it's support Oracle 19c or any other Oracle version before you are going to order this this technology or this solution for your organization. Okay. The other key we have is the TableSpace key. So this key have some attributes is good to know for you. This key is stored and visible in control file and data file header. Okay, so the TableSpace key is visible, okay, in control file or and data file header. And the TableSpace key is used for encrypt all the data file inside or belong to this table or belong to the TableSpace that have this TableSpace key. Okay, and the TableSpace key encrypted by master key. That means this key will be stored in the control file and data file header encrypted, and the encrypt this key, it will be encrypted by the master key and stored in the control file and data file header. Okay, we have here the third key. Okay, the third key is table key. This one and this key also, there is a couple of things is good to know about this key. This key is stored and visible in this key is stored and visible in table data dictionary. Each table have data stored in or stored in the or metadata stored in dictionaries. So you can get the table key from the table data dictionary or metadata or the table metadata. Okay, it's encrypted by master key, same as the TableSpace key. It will be encrypted. Both of these keys will be encrypted in the encrypted by master key. Okay, and stored encrypted. So this key will be stored as an encrypted keys by master key. Okay. So, and also the table key used to encrypt column within the table. So each table have multiple columns. Those columns will be encrypted by the table key. So maybe you're able to encrypt all the columns, one or two columns, which is containing the critical or some sensitive data. You don't want to, if your system compromised or had an attack or has an attack, so it will be difficult for you to difficult for the attacker to retrieve this data, because it will be encrypted by this key. Okay, so I will just show you like an image. This one, this image is showing you the key architecture and how it will be like distributed and the advantage of each one. Okay, so first we have the master key. This key, it will be generated by Oracle Wallet, and our example here will be with Oracle Wallet, or it will be generated or distributed, let's say, by Oracle Key Vault. And this one, the Oracle Vault, it will be like a key distributed server or service. Let's say it's a service. It will distribute keys between all the servers. So this key, the master key, will be stored here, and it will be used by, or stored of course also in wallet, and it will be used to encrypt table key and the TableSpace key. Okay, so this key is used to encrypt and decrypt table key and TableSpace keys. So we have table here, and table have multiple columns, you can see here. And using the table key, we can encrypt one or two columns or three columns where is the critical or sensitive data resides. So as you can see here, we are using table key to encrypt those columns belong to the table. Okay, the TableSpace keys, it encrypt the data files. So if you have TableSpace key, this one will encrypt all the data files belong to that table space. Okay, belong to that table space. So let's do it like this. If I want encrypt, so I generate a table space key, and this table space key will be encrypted by the master key, and this key encrypt and decrypt by the master key, and it will be also, this key will use it to encrypt and decrypt the data file belong to the table space, have this table space key. Let's go to the table. The same. This table key will be encrypted by the master key, which we generated from the Oracle wallet, or we have it from Oracle Key Vault. You can use one of them, of course. Then the table key will encrypt the column, okay, and this column will be encrypted by this key, okay, 1 or 2 or 3 column inside the table. So once you want to encrypt or decrypt those columns, or you need to fetch the data, it will be encrypted and decrypted by table key. We have it here, okay. So this is like a brief description for, or like illustration for how the key management working here in the Oracle TDE. So I'll close this one. So here we finish this section, like showing or illustrating the table key architecture for the TDE key architecture. That we have 3 primary keys or main keys that's used to encrypt and decrypt the keys and the data belong to the table space and columns. Now we will move to the 4th section, which we will go to through the practical side, and we will try to implement the Oracle TDE configuration. Of course, here I will use Oracle Wallet. I will not use Oracle Key Vault or any other hardware security modules. I will use the simple one, which is Oracle Wallet. Note that this demonstration, it will be also applicable for real application cluster. I'm using here single instance, but the commands that I will use, it will run also, and it will work fine because I tested on rack environment. Okay. Note that we have downtime needed here. This need to configure the Oracle wallet. There is a parameter need to be set, and you need to shut down the database and start it up. This configuration also, it's work on the CDB. That's if you have container database architecture. That's when you have a CDB database with a pluggable database. So, and also there is one thing else I need to highlight. Please, regarding the columns, try to refer to Oracle documentation for more further information in case if you need to implement the column encryption, in case if you have this such of configuration, because it will affect the performance for sure. If you have index on that column, or if you have any other related subjects to this column, it may affect the performance of your system. So I please refer to Oracle documentation and try to get more details about this section. Here I just only demonstrate how you can implement this one in your environment. Okay, so let's move to the implementation side. Here I am on the terminal, so I can now check the database. First, let's start with connecting to the database SQL as sysdba. So I have here the database. So let's check the database, select name and open mode. So let's see the open mode from $v database. Okay. Now we can see here that the database is broad and the open mode is read-write. Let's check the BDBs, show BDBs. Now we can see it's mounted, alter, pluggable, database, broad BDB1 open. If you have let's say if you have Oracle database with real application cluster, so you need to add instances equal all. So here we can here you can open all this pluggable database in all instances by this command, but because we have we call it standalone server or standalone database, we don't need to do that. Here Okay, here I am right now opened, so I can show BDBs. So we can see here that we have read write on this BDB. So we done right now from opening and checking the database if it's available for our configuration. So I will clear here. Now I will try to show some parameters. Sorry, here I want to show parameter for wallet. And this one we need wallet, we call it wallet root. Okay, and this one is we need to set to have the, let's say, to have the wallet configured. But before we set this parameter, we need to create inside the ASM CMD, we need to create a directory to have that directory path inside this parameter. Okay, so here we need to ls cd data, we need to go to the data directory ls. We see here we have a broad directory. We need to create here wallet directory, make there wallet. Here we need to enter inside wallet. Then we need to make there, let's say broad, and cd prod. I will enter inside the prod, make there TDE. Here we will store the TDE key store inside this one. So here bwd, so we can see here we have the wallet, okay, directory. So here we can alter the wallet for to have this path. So the command will be like this: alter system set wallet underscore root, which is this one with this path till here. This one will be for TDE configuration. Scope equal SB file. This one does mean implemented on the file, don't implement it on the memory, because this one need a downtime to have it implement in the memory. SID equal star. This is for if we have multiple instances available on for this database. That means if you have rack environment, this will implement for all the instances. Star, that means all the instances. Okay, now I will hit enter. Once I hit enter, we have nothing implement yet. We need to stop database and check again. You see here nothing implement because it's on the SP file, it's not loaded to the memory. So we need to shut down. We can see like shut immediate, and then we need to hit enter. Sorry, shut immediate, and then we need to hit enter. Okay, database is stopped. We need right now to start up the database, but let me just clear some, start up, just to start up to make the command clear for you to see it. Okay, now I'm starting up the database. Okay, I started up the database. So let me just clear the screen. Now, after I started up the database, I need to check the database availability again. So I need to do select name and open underscore mode from $free database. Now let's see, it's prod now and read write. That's good. Let's show BDBs. As we can see here, the BDBs are the BDB here is in mount mode. So I need to alter pluggable database. So I need to prod BDB 1 open. Of course, if you have multiple instances, then equal all. So you can start all the instances together, but here we have standalone, so that's enough. Show BDBs just to confirm that everything is fine. Right now the database is available to create, and this, please make sure that it's available, all the BDBs that you want to use the encryption for them, the TDE configuration for them, they should be available during your configuration. Okay, so I done here. I need to clear the screen. Let's back to our list. So we done here. We perform the downtime, we configure the wallet parameter. Now we will move to configure the TDE parameters and create the key store. And after finish the creating of the key store inside the wallet, we need to use the auto login and other configuration. So let's move to the second one, which is the configure TDE. We done with this one. We will move to this one now and make sure that we are working on the CDB and BDB together. Okay, let's move. We need to show parameter for TDE. Let's see what we have parameters for TDE. We have TDE configuration. Okay, let me just zoom in. Okay, here we have TDE configuration. There is nothing here, so we need to set this one to work with, that's mean the TDE configuration work to with the wallet. So we have this command. So cd, let me just paste it here and let you see it. Alter system set TDE configuration, which is this one, key store underscore configuration equal file scope equal both. That means it will be for the SP file and the memory. SID equals star, that means we'll implement for all the instances if we have rack environment. No harm to use it right now, even with a single instance or standalone database. Let's hit enter. Now let's see the show parameter TDE and check. Yes, we can see here that we perform the configuration for the TDE. Now, as you can see, we done with the parameters. Let's clear the screen. I need now to check the encryption wallet. What's the status? And let's understand the situation now. We can see that the TDE encryption is the wallet encryption is not available. That means it's not available, and the wallet type is unknown. The wallet, all these things is nothing set. Everything is right now. Everything is clear. So we can say that's brand new configuration. So we need to implement the configuration. So let's move now to try to create like a key store. Okay, the key store protected by a password. Okay, before start with this one, let me just zoom out. Let me here ls, we don't have any file. Once I implement this command, you see this one, it will create a key store here file. Okay, I will hit enter. If not created here, that's mean you have something in your configuration and you need to review back again. Okay, the video and try to check what's the wrong that you did. Okay, administer key management, create key store. Here we create the key store identified by welcome one. This one should be complex. Save it in a secure place, and if it's weak, that's it will be easy for the attacker to brute force this password and take it. If it's easy and guessable, let's say, if the attacker able to guess or brute force it, it will be easy for him to retrieve the sensitive data that you have. Okay, now we need to move for, after we create this one, the key store, we need to like create a single sign-on. That means we call it auto login here. We call it, the wallet type is auto login. We have wallet type password, wallet type auto login. So we need to create auto login here. Sorry, not this one. This one I implemented. We need to go with create this one. So you can see here that's SSO file created here. Let me just show you. Yeah, certificate for single sign-on. This command will create this file here. Let me just review the command. Administer key management, create auto-login key store from key store identified by welcome one. Okay, that's this key store. It will generate the auto-login single sign-on certificate. Okay, now let's check again the encryption wallet dynamic view, and let's see what's the status now. You can see here the wallet type right now set to the auto login, and we have now open, but there is no master key for all the databases we have, or this one, the root container, which we have. We have here the BDB seed, and this one broad BDB1. So let's move to now we need to create a key, let's say. So to create a key, we have this command. I will hit here, but we need to make sure that this command is as you can see here. Of course, I need to administer key management set key force key store identified by welcome one with backup containers all. That's mean all the containers will have this key. Okay, this key to encrypt all the keys for the table spaces and okay, for the table spaces and the table keys. Okay, so let's run the dynamic view. Let's see what will have now the configuration inside the database. As you can see, if you have this, that's mean you are in the safe side. Everything is set, and probably the status is open, the wallet is auto login, and everything is fine. Now we have a master key, which is this one. We can right now encrypt the keys. Of course, there's a lot of commands related to this one and troubleshooting and these things. You can also close the wallet, you can open the wallet, you can remove the auto login and change the wallet type to password. All these commands, you can find them on my GitHub account for this lecture or this video. So let me just clear the screen now, clear. And let me just show you what we have done so far. Okay, we have done this one, both of them. We right now configure the database for Oracle Wallet, and we configure the database to be also a TDE. This feature also is enabled. Now we will move to the encryption. We need to encrypt a table space. So I prefer to create a separate table space. And this table space, we will use it to, let's say, encrypt it with the data file inside it. Let's see, let's create first like a test table space. Okay, let me just create this table space inside the BDB. Okay, so we right now reach here. Now we will start encrypting, securing our table spaces, including the data file inside the table spaces. So let me just minimize this one and this start. First, I will create a table space, but first I need to go inside here, alter session set container broad one BDB. That's mean I will go inside the BDB. From inside the BDB, I will create a table space. Of course, I have OMF enabled, Oracle Managed Files enabled. Okay, so it will be easy for me to, yeah, OMF. The table space is created. As you can see here, I will create also a table, which is the table will be assigned, the default table space will be this table space test. Okay, so that's mean this table space created, this table is created inside this table space. So now we will insert some tables, some data inside it. So we'll see if we are able to retrieve. Let me just comment. Okay, let's commit. Okay, now I need to see the table spaces and the encryption status before start encrypting. Okay, so let me just clear the creation. You can get these comments from my GitHub. I will add it below the video so you can follow up with me. So this command will just check the data files and the table spaces and the encryption. Okay, so let's check like this. Now we have table spaces. Sorry, this one will list the data files alongside with the table space name. So we have this one created here, and it will be under this path on the ASM. Let's see the encryption status for this table spaces, for those table spaces. It's a simple command. We can run like this. It will be select table space underscore name encrypted and status. We can see here there is no encrypted on any of the table spaces. All of them, the status is online. That means they are functioning and read-write. The application or the server are able to reach these table spaces. Now we need to encrypt. How we can encrypt the table space? It's a simple command. We can alter table space and encrypt online, and we can using also the algorithm that we will use. You can see here alter table space test underscore TS. That means stands for table space encryption online, using here the algorithm, and I will use encrypt. Okay, that's I'm going to encrypt. I will hit enter. It will take time. This one take time. If you have a big table space and terabyte, it will take time, but it will not harm the. It will be done online. No need to make it offline to be able to encrypt using this one. So let's run the command again here. Let's see if the table space is encrypted. We can see here, yes, the table space is encrypted and everything is fine. Okay, and the encryption is algorithm is AES 256. Okay, now let's after we encrypt, of course we can decrypt the table space and return it to the same status. If you want to decrypt it and you don't want to encrypt it anymore, that's if you need to change, we need to run back again this command and see if it's you can see here the encryption is removed. So just to demonstrate for you how you can encrypt and decrypt the table space. So now I need to encrypt it now. So I need just to show you that the data inside, if I encrypt, I will be able to retrieve the data from inside. I know that this table space having table called employee, as I created before. Just let me clear. So let me just confirm that the table space is encrypted. Okay, just to check the status if the table space is encrypted. You can see here the table is encrypted. I will select star from employee. Okay, let's see, I am able to retrieve. The meaning of transparency that I don't want to add anything to encrypt and decrypt. It will be happen without feeling that this data is encrypted and it need to be decrypted. This will happen behind the scene without implicitly, without the user feel that there is something some operation that's for encryption and decryption. These data are encrypted on the OS level and on the data file level, but if you are using access like this in normal SQL Plus with authenticate or using credentials, you will be able to retrieve data without adding any single command to your query. Okay, this is the meaning of transparency. Okay, So you may ask, I need to select what algorithms are used. So you can use this command. All these queries, I have them on the GitHub. Just I demonstrate for you to see what is the, yeah, you can see that's the encrypted one. You can use v $encrypted _ table spaces, and then you can join it with the table space. And here you can check what's the encryption that you have. Okay, and the status is normal, everything is encrypted, yes, and everything is fine. Okay, now we have another option. If you have you don't want to go with online, we have traditional one, we call it offline. So you can create an offline. So let me just first decrypt this one and encrypt it with offline way. Okay, I will decrypt. Then after decrypt, I need just to check if the table space is encrypted or not. Let's see, we can see here it's not encrypted anymore. So let's encrypt it in online, encrypted with offline way. Okay, so using offline, we need to make sure that we are show BDBs. Make sure that you are inside the container, because this will hold the data and everything for you for the application data. So okay, now we will create we already have the table space. We no need to create a table space. We have already one. I decrypted, so we need to encrypt it back again to the normal. But first we need to alter the table space and make it offline. So alter table space. Then the table space name is test. Table TS stand for table space. Then offline. Okay. Then normal. Okay. Then hit enter. So now we know that the table space is offline. So let's check the encryption and the table space status for all of them. We can see that this table space is offline and it's not online anymore. Okay. Then we need to encrypt. Now, but be careful. This offline is faster than in encryption than online encryption, table space encryption. Because here there is no read-write operation on the table space, so it will be faster to finish the encryption. Okay. Now we need to back the. Let's check first the table space if it's encrypted and everything is fine before we make it online. We can see here it's not show nothing, but let's open the. Let's make the table space online. Okay, you can see here I add the keyword offline instead of online. So let's alter table space test table space online. Okay, let's check. Okay, now I will just write the comment again. We can see here it's encrypted online and everything is fine. If you want to decrypt, we need to do the same. We need to first make it alter the table space to be offline. Okay, we need to alter. So now we will sorry, let me just first clear the screen. Now we need to decrypt using offline. Okay, now we need to first let me just show you the status of the table space. It's online. We need to make it offline first. Alter table space of test underscore ts offline normal and let's do it. Let's show the table space again. We can see it's offline and encrypted. Yes, we need to decrypt. So let's decrypt Let's decrypt now. Let me just decrypt offline. Okay. Offline decrypt. Okay, now we decrypt offline. Let's check back again to see if it's decrypted. We cannot see here. We need to alter database and make it online. Alter table space. Again, the decryption. Again, the decryption will be faster in offline mode rather than online. Okay, because there is no operation on the table space in offline mode. Okay, test and then ts online. Okay, let's enter the table space and let's check back again the query. We can see everything back again to the normal. Okay, so here I am done with encryption and decryption. Now maybe you will need to rekey, like changing the key to something else. So let me clear. Before starting rekeying let me just go to the original document to have like recap what we have done so far. We have TableSpace encryption. We done online encryption decryption. We done offline encryption decryption. Now we will rekey the TableSpace. What I mean by rekey the TableSpace, once we encrypt, we use the key AES, let's say 205 6, let's say. We have a lot of algorithms, so maybe you will change the algorithm for something else, maybe for something secure, more secure, for something is better than the algorithm that you have currently. So maybe you will force to have rekey the TableSpace key. So let's go through this step. Okay, and this is the last one for the TableSpace. Let's do it. So we need to encrypt again the TableSpace. Let's use the online one, which is faster one. Let's first check the status of the TableSpace. We know that it's not encrypted, so let's encrypt using online way, which is faster right now because it's a small TableSpace. You can see here. Now I need to copy this one, the top, just to make it faster. Let's see. Yes, right now the TableSpace is online, and yes, it's using the encryption. So let me clear. So I need to check what's the algorithm, okay, that's used to encrypt the TableSpace. So maybe I need to change it. So how I can check what is the algorithm? I can use this query, this dynamic view encrypted underscore TableSpace. You can join it with a $v TableSpace, another dynamic view, to have the encryption algorithm and the TableSpace name and the status and the encrypt for the encryption, if it's yes or no. You can see here we have AES 256. If I want to return this to the default one, I need to rekey the TableSpace. So how I can do that? It's simple. We need to first use a command, rekey. This is the command I will alter. Let me just alter the TableSpace I have. Then I am encryption using, I'm encrypted again using this key. Then I will use this keyword, rekey. That's mean I have already key and I need to rekey. I will hit enter. Now it will rekeying that mean use a different algorithm to encrypt. Let me check. Again, we can see here in this one the encryption is algorithm, or the encryption type is changed to something called AES 192, which is the default, I think. No, I think this is default for column encryption. Sorry, this is default for column encryption. Okay, so we done here for the tablespace encryption. So let's back to our list. So we done all of this. We right now perform the online encryption, decryption, offline encryption, decryption, rekeying as well. Okay, now I will move to the column encryption for the table. We have table key. We need to encrypt the column using table key. So let's move to that one. Let me first clear the screen here. Okay, and now we're done. Let's move to the column. Before we start with column key, column encryption within the table, just here I need to highlight one thing. Column key is you need to think twice before implement it, because maybe sometime for sure it will cause some issue and performance issue for SQL in case if you have transactional database on these things. So please study this well before perform it on your production environment or as a solution to secure your database. For me, I prefer tablespace that's encrypt all the tablespace. So once you have it, you have all the data file are secure, belong to this tablespace. So please study this well and try to refer to Oracle documentation before implement this one on your environment. Now we need to create a table, but before we create the table, we need to create a user. So to create this user, we need to make sure that we have a couple of things are prepared. Okay, so let's first try to check if we have at least the proper service name. So let me just first cat the Aura TNS names .aura file, which is let me just cat it here, Control V. So as you can see here, I have this service name. This is the service name. This is the domain name. So this one I put it because you can see here, I will show parameter, just to parameter, okay, domain. So you can see here the DB domain parameter is set to Aura domain. So here I will put the show BDBs. The service name will be the container name dot the Aura domain, which is the database domain name. Okay, so let's do the TNS Bing for prod BDB1. Let's see, we can see here it's okay, 10 milliseconds. Now let me just clear the screen. So now we know that we have everything is set properly. So we need now properly set properly. Sorry. Now I need to create the test user. So the test user will be like this. I will create user TST underscore user identified by password. This is the password will be default table space user. This is where we store the data, quota and limit on user for this. So I grant him unlimited quota on the user's table space. So let's hit enter. Why I'm doing this, why I'm creating, because I cannot like encrypt any object like any column for a table inside sys schema. Show user, So you can see here, I have here sys user. So I cannot encrypt any table. I will show you now before I'm switch, but let me first finish creation of the and granting this user the privilege. So I will grant this user the privilege to access and use resource. Now this I will grant also select any dictionary. So I will be able to check the metadata of the table from within the user. So no need to switch from TST underscore user to sys user to check the data of that column, those columns that we will modify, or the table metadata. So now, as you can see, I finish creating and granting some some privileges that's need to create a table inside this user. But first, let me just try to create, and let's see what's the error that I will get. I will create from sys. It will show us that there is an error. You can see it now. Cannot encrypt sys. Remember this, aura 28336 cannot encrypt sys-owned objects. That means we cannot encrypt the table columns within the table inside the sys schema. So now let me connect to TST user. So I will use connect. Let's connect, and then I will put this one, and I connected show user. Let me see. Okay, I am the user, TST user. Now I will try to create the table again, okay, within this user, but let me first clear the screen. All these comments again, you can find them on my GitHub repository. I will share it below in the video, so you can follow up with me with this. As you can see here, the table is created and everything is fine. Let's see the encryption. Because I grant the select any dictionary, so this user will be able to read this table. You can see here that we have 3 columns encrypted with salt and mac. Okay. Now we can see that everything is fine. We can see the default is AES. This is the algorithm, encryption algorithm is the default. Let's try to change to create a column but with different encryption. It should not work because, as I mentioned before in the beginning, that we cannot use different algorithm or different encryption key for in each table. We have multiple columns, so we cannot encrypt by different key for each column. So if I try to add, let's say, this column, it should not work. Let's say if I want to add this column called cust SSN, okay, this one, it will not work. It will tell me that's missing or invalid encryption algorithm. Sorry, I think here it's I need to put 256, let's say. I will change it. Sorry. It should be like this. Okay, I will use this algorithm. It will tell me different encryption algorithm has been chosen for a table or table space. That means this table have this as a default key, so I cannot use another key or another encryption algorithm for the same table with different for the same table with different columns inside it. So I can do it like if I let me just drop this table. Let me just drop this table. Drop table customer. Okay. Okay. Drop table. Sorry. Customer. I forget, it's a typo. I made a typo. Okay, let me clear the screen and let's create the table with different let's say with different form. You can see here I encrypt with no salt. Here I use encrypt, but here I am using the key AES 256. So it should, both of those should be the same as this one. It's not the default 19. Let me just first create it, and let's select again the here. Let's see. You can see here, if I use this as a default here, or as let's say a key encryption algorithm, the both will not take in the default, will take this one. So AES 256. Now let's add that column. Now I can add that column. So you can encrypt the column in the creation time. Now you can create like this, add and modify. So let me just back to this sheet, this list which we started. So for the column encryption, we add a column to the table, and we can see here that we created within the creation time. But here also we have already the table. We add to the table a column, and this column is encrypted. So here we done with this one. Now we will move to modify and modify encrypt column to table. So we can now try to modify the column, okay, within the table. So let's try to modify. Now you can see here this column is not I have no salt. So you can see here so here there is some other attributes. We can change them, but let me select again to see how many. I think now I have 4 columns. They are encrypted. You can see here we have a customer SSN number, which is the same, the default one 256, and the salt and MAC, both of them SHA-1, and the salt is enabled. Now I need to modify the cust name and encrypted. Already the customer name is already there. You can see it. It's not encrypted. So I can modify and encrypt that column. So let me just encrypt like this. This is the SQL statement: alter table customer, modify cust name. That means customer name with encrypt keyword. So this will encrypt the customer name column. Again, let's select and see if it's encrypted and what's the attribute of that encryption. Done. Okay, you can see here the customer is encrypted, and the owner is TST, which is test user, and the table is customer, and you can see here the column name and the encryption algorithm, and the salt is enabled, yes, and SHA-1 is the MAC. Okay, now let's of course we can put also no MAC. Let's try this one with let me just modify the email and make it this one, the email, and make it let's say no salt. Okay, it's easy. We modify the column again. You can see here like this, alter table customer, modify the cust email, encrypt no salt. Okay, the email encrypt no salt. Column is already encrypted. That's mean yes, the column is encrypted, so we cannot re-encrypt again, but we can change no salt without this one. Sorry for this one. So let's let me just try to check another column that's have no encryption yet from within this one. I think we have the name, we have the email. Let's do also the ID. I think ID we have is not encrypted. Let's or before encrypt the ID, let's decrypt one of them and try to modify. Let me just, I need to decrypt the email. Let's say I will decrypt the email. Okay, or the customer name. Let's do it for the customer name. Okay, I will do it for the customer name first. I will decrypt. You can see here alter table customer, modify cust name, and I will decrypt here. Okay, so you can see here the customer name is, you can see here it's not now it's not encrypted anymore. Let me just check to confirm. This one will not be in the list. Customer name should be removed. Right, customer name is removed. Now I will remove also the customer email. Let me just decrypt the customer email. So email decrypt. Okay, let me just decrypt also this one. Let me just try also to select again the DBA encrypted columns. Let's see. Okay, the email also gone. So let me now, I need to encrypt the email again and try to put the attribute with no salt. Okay, and also let's say also no Mac, and let's use also no Mac. Let me just check. There is a lot of query that you can perform. We can encrypt it back again. Okay, so let me just select the columns again back. So you can see I add them, and here no salt. You can check the Oracle documentation for encryption and encrypt and decrypt options for the column. A lot of combined commands together, but here I'm giving a brief way how you can manage this, and some like idea scenarios how you can do it. Let's say here we are modified. So let's go back, and we can see here we create a table and we encrypt within the creation time. We add, you can see here we add a column and we encrypt it using a specific algorithm. This algorithm should be the same as we have on the table creation time if we have already some encrypted columns with the table. Okay, now we can see here that we can also, as you can see, we can modify. If we have something not encrypted, we can modify and encrypted. We can also decrypt. As you can see here, alter table customer modify, customer name, we can decrypt it after we encrypt it. Now we also here decrypt the custom employee, and we encrypt it back again with no salt. You can see here we did like the major scenarios that we have. Now after I finish both of those sections, now you may ask, okay, if I want to change this one, how I can do that? We call it rekey. That means I need to regenerate another key or recreate another key with different algorithm. Okay, so we can do this by let me just clear the screen first. We can perform this with simple command. I can alter the customer. You see, customer rekey using 3dis 168. This is another algorithm available. Okay, so if I alter like this, this will rekey this will rekey the key for table key for the customer table. So we can now select the table, the DBA encrypted columns to see. Yes, we have now a different 3 key triple dis 168 bits key. Okay, so that's mean we able to change it. If we want to return back to the AES, we can alter like this using, and we can paste and put AES, let's say 129. If you want to back to the default, we can rekey like this. Again, select, we need to select again that this one, and we can see now we back to the default. So now I will back to the conclusion here. I'm done here. So you can see here we have a long journey. I know it's a long video. We have an introduction, we have a type of, just here to recap, we have an introduction, we have here a type of TDE encryption target. We know that we are using TableSpace columns to encrypt using the TDE feature. We know that we have three types of keys. The first one is the master key, which encrypt the TableSpace key and table key. And we know that we need to configure the wallet. To configure the TDE, we have a couple of parameters we need to set. We see here we have wallet underscore root. We need a downtime to configure the wallet. Here we need also to configure TDE with TDE underscore configuration parameter to set the type of the configuration to be a file. And we need also to create a key store inside the wallet and to store all the master key inside it, which this key will be encrypt the TableSpace key and the column key. We know now that the TableSpace have two ways to encrypt: online, which will take longer time, but you will keep your system available. The offline is the faster, but you need to bring your TableSpace offline to be able to perform this one, encrypt and decrypt. So we have also changing the key for the TableSpace. Let's say you have AES 192, you can change it to AES 256 algorithm, encryption algorithm. For the column, the same. You can create the encrypted column within the table creation, or you can add that column and encrypt it with adding that column to the table. Or if the column already created on the table and you want to encrypt it, you need to modify that column with the encrypt keyword. Okay. We can here also rekey the table with another encryption or encrypting algorithm. So that's it all. I hope this video is informative for you. A lot of information, I know, and there is a practical side. Please refer also to the link below for more details on my GitHub. There is a full document for all what I wrote here if you want to follow alongside with me. Thank you for watching, and I hope to see you next video. Thank you.